So welcome everybody. Thanks for coming to our workshop today. I'm going to be talking about EyePop.ai's platform, as well as the goal for this particular workshop is first, we're going to learn about creating endpoints on EyePop.ai. We're going to look at an app built on those endpoints and just do simple file uploads to find both people, their pose within the scene, as well as a custom model that I've trained around eyeglasses. We're going to learn about removing the background from people, and we're actually going to be using a technology called SAM2 to do that. And we're going to learn about how to use EyePop.ai's live endpoints to point a live stream to our endpoint to autofocus to that person in the scene, regardless of where they are in the visual frame. And so with that, let's get started. The first thing I'd like to present to you is just a little bit of background about EyePop.ai. And let me share my screen and we're going to switch over to Canva. Okay. So what is EyePop.ai? EyePop.ai is a self-service AI platform designed to make it easy for people and businesses of all technical levels to create apps and detailed analytics based on perception AI. And so to dive in there, we're self-service. And so there's no sales call to get started. This is a place for you to go in and play. You can dive in right away with a free account and get started developing against your own AI endpoint. We make it easy. We have a consumer level UI. We have web dev accessible APIs, and there are some no and low code options as well, especially as it relates to creating custom models around the objects that you want to find in a visual field. And we're starting with computer vision and expanding from there. This is how EyePop.ai works. So we create API endpoints. We call them POPs. And a POP is really a computer vision recipe coupled with an AI worker server in the cloud. And a little bit later, we'll talk about some of how do I deploy this to the edge. We have some capabilities there. And what you do as a developer is take your unstructured business data in the form of images, video, or live streams. You connect with our SDKs. These are really easy to use, and we're going to be talking a lot about how to use these today. That connects into your endpoint, which is your POP, that's running a computer vision recipe. That your POP will handle a pipeline of models. We find often in computer vision solutions for the real world, it's not just one model that gets the job done. You need a combination of models all working together. And all of the output of those models is then structured into a JSON data object. That is going to be good for integration into really any type of product that you have. And so in your product, you can use that for taking action. So you see a condition or object in a particular image or video, you can take action and make a new user flow. You can use that for communication. You can use that for deep analysis about your user's data that they're handing you, or discovering new use cases within the data that you have. Um, Today I won't go into this too much, but there's a lot of work to operate a computer vision model yourself. I think the biggest one is really choosing the right model, understanding what type of model you need, and then curating the models out there. It can be pretty daunting if you don't have experience in this area, and it requires a lot of trial and error. We've taken a lot of that work out by uh, producing curated pipelines on our system, as well as allowing you to train your own model that's based off of your data. And so it's going to work for your specific use case. Once you have a model, there's a lot of setup around ingesting media like images and video and getting them in the right tensor format in order to run AI. There are some things called normalization. I won't get into that. Running the model, typically frameworks make this relatively easy, but then on the post-processing side, you also need to make sense of that output. Every different type of model is going to have different outputs. This often involves reading white papers or other developer documentation to understand how to get meaningful data out of those models. We've made that super simple by structuring that into a standardized JSON that you'll get regardless of the type of pipeline from EyePop. And then once it's out there, how are you monitoring that model in the field? We have systems in place to allow us to help you monitor your model as it's working in the field. Is that the right model? Is it right for the conditions that you've deployed it to? And as you discover edge cases where it fails, we allow you to retrain those models really easily to deploy a new version and get back up and running. This is an example of one of our customers. They send out medical lab sample couriers to pick up these medical samples, and they want to know in real time, did I get the right number of samples for this location? Are they the right samples that I am supposed to pick up? And we're able to use computer vision in real time. And this is actually a real photo from one of our booths where we allowed people to pretend to be a medical a courier and actually try it out ourselves. So super exciting. They're able to use computer vision in real time, take a picture, ping their database with that structured data, and understand if these are the right samples at the right location at the right time. Um, our proprietary CV pipelines are all made up of lots of different models. This is one of the more complex pipelines we have, and this pipeline is our person 3D. It has face mesh, hand mesh, body three-dimensional points. And so when we think about how we use our pipelines, it's always generally from a place of we're going to use multiple models at the same time working together. I don't want to go into this too detailed, but if we have time at the end and you have questions about the different types of pipelines that we have, we're going to be looking at people today, both from person detection as well as person detection with 2D body points. Um, we have face, body, hands in 3 dimensions if you need that for your project. Common objects, people and animals, people and devices, people and sports equipment, vehicles, text detection in the real world. So this is not just OCR, but it's also finding text out there on real products that can be curved or oriented in different ways. Traffic cam data, sports player tracking, person demographics, and then we're going to be looking at this today too, working with your own model and combining that with other curated pipelines that we have. Okay, and so I'm going to stop there on the presentation and let's get into some actual coding. But before I get started, are there any questions so far? Okay, great. This workshop's meant to be pretty interactive. I'll stop at the end of each little subsection here and just check in for questions, but please let me know if you have any questions in the chat. Happy to stop and answer those. All right, this is the EyePop dashboard. This is where we're going to be creating our endpoints today. And that's the first part of our computer vision solutions to upload and find people, remove the background for people in the scene, and autofocus to people in live streams. I'm going to show you the 3 different ways we have to create endpoints. 2 of them are through this UI, and 1 of them is in the code through our SDKs. So everything you can do here on the dashboard, you can also do through code if that's your preference. Okay, so let's see. Let's get started. Let's create a new endpoint, and today we're going to be coding against our endpoint. So we're going to want this API pop. And we're going to call this person 2D. And what this is doing, this account I'm working on today is at our developer level account. Our developers get to pull AI worker servers out of a common pool. As you think about productionizing your endpoint, you want to move up to our production tier, which gives you guaranteed capacity. You don't share those servers with anyone else. But as a developer, I get to pull one of the AI worker servers out of the pool. That AI worker server is mine only, and it's wiped before it's put back into the pool. So there's no sharing of data or sharing of logs or any sort of thing like that. Today, we're going to be looking at person with 2D body points, and you can see the pipelines that we talked about in that presentation are all here, as well as my models that I've trained for other demos. Okay, and it's that easy. So what this has done is I've selected the person with 2D body points. It's going out to my AI worker server, and it's setting up the collection of models that are running on that machine. On my dashboard here, I now have React and JavaScript example code that I can run right away. I also have Python code here that I can cut and paste and run immediately against my AI worker server. We also have several plugin integrations. You can use us with Zapier, with Bubble, with Mind Studio. That list is ever growing and offers good low code scenarios if I want to interact with my pop in that way or connect them to other services. Okay, the first thing I'm going to do is let's just test this pop out in our preview experience. What this is going to do is load a small sandbox where I can upload images. And so the first one, we're looking for person with 2D body points. I uploaded a picture into that. It came back right away with this structured data. And let's take a look at this data before we get into the code so we're a little bit more familiar with how the responses look in EyePop. So we have our objects array, and we can see it found one object. That object is a person. This came back with quite high confidence, and it's giving me information around the box that describes this person. And that box has a height, and here, let's close this. It also has a width, X and Y. And so that just describes where it found the person in the scene. In this example, it takes up most of the visual real estate. And it also found key points. And these key points are 2D body key points. There are situations in which you might have multiple types of key points for a particular object. And in here, we have our points object with our labels of what that point means to a human, the confidence at which it found it, and the X and Y here. Now, there are more key points that are possible to find on here. And so we have things like hips and ankles and things like that that are not shown in this image. We have this through the UI set to 25% confidence threshold. We can see the things that it can see are, it's very confident about those particular features, like left eye is very clearly visible, so it understands that very well. Whereas if we look at something like left ear, which is not as visible, it's a little less confident there. And there are some points that are not even included here because we have it thresholded at 25%. And so if it is less than 25% confident there, it's going to not even include it in this thing. There's ways to configure that pipeline, though, if you want it to guess a little harder. We can look at a little bit later how you would configure this pipeline yourself without going through the UI. And there's more options in the configuration process. So that is one way to look at our pops. Another way, all of our pops are available to use through images, video, and live stream. And so we can also point our live webcam here, and it'll just take a moment to spin up and form that connection. And once it's formed a connection, it will start doing inference in real time. And so we can see here that it's creating boxes and body landmarks in real time. The thing I get as part of the response in a live stream or video scenario that I don't get as an image is I get this tracking ID. And this tracking ID helps me trace an object from one frame to the next. And so I can see that I have a unique identifier here that is ID 3. The person that's described by ID 3 in frame 1 is going to be the same person in frame 2. And so in my code, I can understand that even though we're finding people in lots of different frames, they're threaded together with a unique identifier here. And so I know that this is the same person just over and over time. Okay, any questions there before I move on? Okay, great. The second endpoint we're going to look at today is a modification of the person with 2D body points endpoint. And so I'm going to go into my models for this particular endpoint. And in my models, I'm going to scroll down and show you how I created this model around eyeglasses. And load this up. Okay. So I've gone ahead and loaded over 600 images into this data set. Our platform auto-labeled these images based on the label I gave it, which was eyeglasses. And then I went through and human approved these labels. And so we can see an example of what the machine thinks is eyeglasses, and it's showing me it's guessing by this dotted box here. Again, we can use confidence threshold to dial in the guesses to its best guess. And so the first time through, it uses the EyePop.ai auto labeler, which is a foundational model that knows a variety of objects, and it's going to try its best guess at the eyeglasses are in the scene. And the next time through, it's going to use my model to start labeling. And so we always are in a place where we're auto labeling, and those labels are always just going to continue to get better as I progress the model. And so I'm on the 10th version of this model. And so the previous version of the model, the bounding box, was a little light here. And so I might want to rearrange that and just fix it up there. This process, once you get into it, is very quick. I labeled all 650 in about an hour, and then started training and had went from a pile of images to a deployed model in about 2 hours. So not too bad there. There's a lot of things I could look at here these in these images. This is a good example of maybe I want the model to only focus on the eyepieces of eyeglasses. And so I'm going to want to be consistent about how I label these boxes. In this model and data set, I've labeled all the visible real estate of eyeglasses. So it includes the stems too, if you can see them. And I've gone ahead and finished out the rest of these labels. When you're done labeling, you get some pre-training stats. And this lets you know if you are ready to start training with a model. We want to make sure that you have enough data in there that you're going to get something of quality. And so it's going to give you a small score here. This is looking good. It's talking about how many images I've gone ahead and labeled. It's going to talk about the images that I've used as negative examples. Those are images without my object in it. These are really important for the model to have a robust model. And case in point for this particular model, before I added negative examples, which are people without glasses on, it really was confused if I took off my glasses about the eye region of people, because the only examples of people I had given it before that were people with glasses. It understandably thought, glasses could just be around the eyes. And so by adding 22% of my images in here as people without glasses, it started to understand, okay, people in glasses are different and the eyes in glasses are different. If I wanted to, I could go upload more images. More data is better. I could go and review my labels to make sure they're consistent or add more labels to it. And then I just hit start training. And so what happens after that is I'm going to jump back to my models. I've already trained a version of this model earlier. And so we're going to take a look at that. And so if we look at the latest version of my eyeglasses model that I trained, we can see some of the stats around what I built here. And so this is one way to look at stats for a computer vision model. It's precision versus recall over the confidence curve. What we're looking for here, ideally, is to take up as much visual real estate in this one by one box. So this is actually not bad. This is pretty good, especially for demonstration for my model. Now, I want to be able to use this model out in my POP endpoint. And so I'm going to deploy it to the cloud. We also have the ability to deploy it to the edge. And we have another workshop that talks about that. And we use a technology by Qualcomm called the AI Hub to help optimize for Snapdragon devices, if that's the target that you want to deploy to. But I'm going to compose this model with person in 2D body points. And that means when I send it an image, video, live stream, I want you to find eyeglasses and person, and I want you to find the body points on that person. And so this is one way to compose a pipeline through this UI. You can also do this in code. So I'm going to create this right now. It takes just a few seconds to go out to an AI worker server, load up my model, load up the person models, and now we're ready to go for inference. I'm going to load in that same picture of myself. And so now, in addition to the person detection as well as the body points, I'm getting eyeglasses as well. It all comes back in the same response. We can see I have two objects now, the first one being eyeglasses and the second one being person. And now I can do interesting things to interrelate these two components. Number one, I could look for, are the eyeglasses that you found positioned near the person's eyes, and start to infer things like, are they wearing the eyeglasses, or are they holding it in their hand, or is it just on the table around them? So lots of questions I can start to ask about this particular model. And again, if I wanted to do this in live stream, I can wait for this to spin up and warm up to form that connection with my webcam. And then once that connection is formed, we'll see that doing inference live and actually looking for the eyeglasses in the scene. And so one of the things that I have noticed about this eyeglasses model is it works better. You can see sometimes it'll double up. It'll make more guesses than it thinks are correct. And the way to control that is by setting a confidence threshold. This model works best at around 0.8. And we can see it's solidly finding just one pair of eyeglasses there. All right. The third way we can create an endpoint is in code. We're going to show that in the code section. And so I'll stop here. Does anyone have any questions about creating endpoints through the UI before we get into the code? Okay, excellent. All right, so we have our two endpoints we get to use. One has a custom model that we trained through EyePop. And now let's start to actually create some interesting apps around this. And so the first thing we're going to do is go to our developer docs. In developer docs, we're going to be using the Python SDK first. So you can go and check out our Python SDK GitHub if you're curious about how it's communicating with EyePop. We also have this demos GitHub. And in demos GitHub, you can see, here, let's jump into Python. These are all the examples we have in Python. There's actually quite a few things we have kind of taught about already. We're going to be looking at this person detection workshop. And so I've already loaded that up into my IDE. And we can see that same person detection workshop folder here. I am going to bring up a terminal interface, and we're going to be doing some things here. So let me explain what's happening here. Let's look at this number one example. This is the simplest example. It's sending a single photo through the EyePop SDK for inference, and we're not going to do anything but just dump the results back out, very similar to what we had been doing in the preview UI there. So we're importing the SDK. If you need to install this, it's a pip install EyePop, very easy. We're also importing JSON for pre-printing the JSON results that we get back. And I'm loading up environment variables. These represent my POP UUID and my API key. And if we jump back to the dashboard, the way I get my POP UUID is by copying it here. You can see it also directly pasted into the code that I would cut and paste to create these examples. And my API key I would generate. There's a button on your POPs here. I already have created an API key here that I've cut and pasted into my configuration. All right. We're going to select which photo we want. I've got two prepared here. If we look at these two, I've got one, this guy is looking pretty dapper. And number two, this woman jumping. This one's an interesting one because it's a full body shot. We can see every key point that EyePop has to offer for 2D body points. And so we're going to be sending this in. We could be doing something a little fancier here. We could use a file picker or a argument for our Python, or even just connect it to the webcam itself. We're just going to pass in the path very simply here. We are going to pass our POP ID as well as our API key into the worker endpoint. This is how you instantiate the worker endpoint. And then to do work, we're going to be using the endpoint object. In the Python SDK, the way we upload an image is by calling the upload function and then predict. And that's, so this will upload it to my AI worker server. This will get the predictions back from the AI worker server. This puts it into a variable called result, and then we're going to dump result back out to the screen. And so let's I'm using Python 3.13, and let's try out number one. So again, I haven't used this particular pipeline in a little while, so it's going to take a second to load up. That's pulling the AI worker server out of the pool the second time through, and we'll run it again twice so you can see the speed difference. It'll give me results immediately there. And so here we are. Here are the results that I found. The endpoint I connected this to was similar to what we created just now by deploying the eyeglass model. So we have both eyeglasses and people and their key points all in this response. And we can see this is very similar in structure to what we had just been looking at. If we run that again, we're going to see a much faster response because now our AI worker server is out there configured and warm. So we can tell this is working. We are connected in correctly. So now let's do something a little bit more interesting with this. The next thing we're going to do is let's just visualize what we're getting out of there with the Python SDK. And in this first one, or in this visualization, we're doing pretty much the same rundown to start with, but we're also going to take Pillow and we're going to take Matplotlib in order to do the visualization steps. Again, we're going to set up our AI worker endpoint. We're going to upload and predict. We're going to dump that back out to the terminal. I've added this optional step here. If we want to filter objects by confidence, this is one way you can do that. And right now we're not filtering anything because I have it set to 0, but we could set that to any number between 0 and 1 to form a threshold at which you need to be above to be visualized in our demo here. We're going to show the image, and so we're going to take that same image and visualize it to the screen. We're also going to use the EyePop Python SDK to plot the boxes that we found to the screen. And on the Python side, this renderer really just plots boxes. We have an example in the next section of how to plot the key points as well in Python. It's relatively easy. We're just dealing with X and Y coordinates here. That's pretty much it for this. So let's take a look at what that actually looks like in practice. Okay, so it went out to our AI worker server, it uploaded that picture, and it came back with these boxes, and now we visualize these boxes on a Matplotlib kind of canvas here. We can see this pipeline gave us back person and eyeglasses, so it's that combined pipeline. We know that from the terminal, we're also getting back key points, but that's not something we're visualizing yet, so we'll do that in the next step. So let me close this out. And lastly, we're going to take a look at our full example. This is going to add visualizing the key points as well, because we have key points on people and not eyeglasses. We have a quick, kind of filter for what the class label is here. There's lots of ways we could have done this. We could have also just looked for, these objects to be within the overall object, but this is one way we could do it. And then for each of those points that we find, we're going to print them out, and we're also going to plot them in this nice light blue circles. And so let's do that. Okay, and we're using the other image here this time around, but we can see it found the person, and it's also visualizing all those key points on the image. And so everything we're doing here can be done in really any language, but especially React based language, Node based language, Python languages. I'm going to show different things in each language just to keep the workshop moving, but you can do really any of these things in either language. And so lots of options here. Before I move on to React, does anyone have any questions around the Python piece of this workshop? All right, excellent. All right, so here's where we get into some more interesting examples, in my opinion. Now that we have the basics down, we can start to get pretty fancy with it. And so let's close that out. So I'm going to close out my Python code and terminal, and we're going to start looking at the React side of things. And so the first example I want to show today is creating our pops in a different way. And so we're going to look at how do we create pops dynamically using just code. And so instead of going to the UI and composing our pop, we're going to compose it through this change pop maneuver. And so in React, just like in Python, we have our SDK import. We're also importing, in React, we've separated the render and the SDK to do work. This renderer is more complicated than the Python one and can do more things. And so these are all things you can build yourself, but to visualize things easily, we have it in a library. Up to you if you want to use it or not. We instantiate our endpoint. And so very similar to how we do this in Python, we call worker endpoint. We're giving it a pop ID. Now, this time around, we're going to give it this pop ID called transient. This is actually not necessary to do. This is the default. This allows us a blank canvas to start creating our own pop on top of. So instead of giving it a pop ID, we're going to give it a definition later. We're also going to authenticate in with our API key. And these are extraneous parameters. You don't need to worry about this. We're going to then connect to our endpoint, and we're going to await that connect so that we are all connected up before we try to start changing that pop. When we change our pop, we're going to call it change pop, and we're going to give it a pop definition. I'm going to jump in here because today we're going to be using, and this is for our sticker example, we want to remove the background of a person and create kind of a sticker effect. And so the way we're going to do that is by first referencing the SAM2 encoder. We're going to forward that encoded library into the person model. And so this should look somewhat familiar because that's what we were doing on the other side. And so we're using eyepop.person.latest or colon latest. This is great, especially for my models. I may want to pin a specific version of a model in my code, or I may want to say, always give me the latest so that when I deploy a new model, it automatically gets picked up by my integration with my code. Up to you about version control and how you handle that at your company. But two different ways to kind of think about that there. Once we have the person detected, this is going to generate a bounding box. We're going to forward that bounding box into the SAM2 decoder, and that's going to allow us to find the outline of a person in a scene. Once we have that outline mask, we're going to pass it into the contour finder. That contour finder is what creates a polygon that we can draw to the scene and do interesting stuff with. So I'm going to start by let's take a look at what this looks like in action, and then I'll go back and kind of explain how that code works. And so I'm going to refresh here. You can see it was already pinned to the demo that we're going to be talking about last. And so we're connecting into our EyePop worker at this point. The first time, again, it's going to pull one out of the pool. We're going to switch over to our sticker effect, detect person, and sticker them. This is going to pull it out of the pool. It did that, and it's going to load up SAM2, which it just did as well. Now, the first thing I can do is I can just take a picture with this UI. And so let's take a picture. And it's going to send it up to my AI worker server and send back that polygon. And so there's a lot of effects we could do here. Aside from putting this goofy outline around me, we could have feathered the end of the edges of this polygon. I could have put this against a like dimmed background or blurred background like Zoom does. There's lots of things we could do with this mask that are fun effects, but right now I can save this, and now I have a sticker of myself kind of like you would do in Apple by holding down on a person. Same sort of idea. I can also upload an image into that. And so if we again upload that rather dapper individual, it's going to process that image. It's going to come back with that, and we're visualizing it here. So any questions about background removal before I get into the code of how we did this? Okay, fantastic. All right, so let's keep going. So I'm going to jump into how we made that happen. So we already looked at how we set up the pop in the first place. The only other interesting thing we could do here is set up a renderer. We're actually not using this in the sticker example. I'm doing custom code to render that white polygon around the person and remove the background. So we'll look at that. But this would render a nice IPOP blue polygon around your thing if you don't want to build your own render code. In our page TSX, what that's doing is setting up this camera preview. It sets up the pop. It has the settings. So really just boring UI type stuff in there done for you. There's 3 modes this page works at. I can take a picture using this button. I can upload an image or a video using this button. And just by sitting back and letting it happen, there's a process frame call happening here. So if I need to use a live video example, which we're actually going to do next in dynamic person cropping. It's just happening automatically in the background against this camera preview here. And so what that does is when I direct this to either upload a photo or to take a photo here, it's going to call on our processor this function process photo. Here I can give it things like the file or blob that represents the photo, the canvas I want to draw it to, it optionally a name of the file or a region of interest. We're not going to be talking about these 2 parameters today. They don't really have any bearing on this kind of sticker concept. But these are things that we could do some interesting things with in some other applications. In this, I'm caching results. We are not using this cache today, and so all of the things you saw just now were that was real time, and that's how long it takes. But if I did want to cache some of these sticker results, I could do it with that. And once I get through the caching logic here, the real meat of this is how do I send this image to EyePop to do work? And so I already have my connection with my endpoint. I'm going to use this endpoint and I'm going to call process. So slightly different syntax than our Python SDK. This encapsulates the same concept as upload and predict together. And so it's one call instead of 2 different functions. I can pass this process a file, I can pass it a URL, I can pass it a blob. It's pretty flexible in what you can pass it. I can change this MIME type, I can pass it videos as well. That is going to bring back a result promise. We're going to await that promise, and for all of the results that come back, I am going to log them out to the console, and I'm also going to give it to this variable called draw result. If we have a draw result and that draw result has objects and we saw what those objects could look like, I'm going to save it to the cache, and I'm also going to start to visualize it. And so the visualization code here gets pretty interesting for that sticker effect. One of the things that I need to do first is I'm going to take the entire canvas as a blob. That creates a snapshot. I'm going to save that to a new image. And when I have that new image loaded, I'm going to call a function called lift contour. What that does is it first draws the snapshot that we took to the screen, and then it's going to context save. This is going to allow us to recall context later. Then we're going to clear the entire screen. And so that is going to allow us to start fresh on the canvas. We're going to go through our contour points. And so the way contours come back, and we can see a nice console result here, is it comes back as part of the image. And let's, do I have a current one? I suppose not. Okay. Let's do this again. So we're still on person detection. Let's take a sticker. Let's refresh and connect here and sticker it up. Oh man, that's going to be, oh, need to change over to person. Okay, great. All right. And so that's sending it out to our AI worker server, and it came back. And this time it didn't like my EyePop t-shirt as part of myself, but we're going to look at this object. And so just like in Python, we're getting back an object. Because we're using the SAM decoded segment, we're getting back a mask. That mask has contours. And that contour, this polygon that describes the edges of the sticker, are just an array of points. And so we have a ton of points in here that we're drawing to get this nice contour here. And so if we look in our contours, we're just looping over that list of points. We are scaling the point to normalize it to the screen. So if you use the renderer in that comes with the EyePop SDK, you don't have to worry about these sort of normalization. It just does it. But this is what we're doing behind the scenes, is we're taking how big is that image? And we know that because we get that back in the source height and source width. And how big is our screen? And let's match those things together with by using essentially an aspect ratio here. And so we're scaling up the X and Y to appropriate coordinates so that we're visualizing everything on the same normalized canvas. And then we're closing that path. We're going to form a outline by drawing a line around that polygon. And then we're going to clip that path, which is going to, if you can imagine this drawing a big polygon, it's going to save that region so that we can destroy everything else on the screen other than that region. In this case, we're going to just draw from that snapshot that we had in the beginning into the region that's defined by the polygon. And that's how we get that black outline, or the black part that's, oh, we gotta, let's refresh here because we were messing with it. And oh, of course. Okay, and so we can see this is the part that got cleared when we copy pixels back into the canvas. We're just copying the pixels back into the region that is described by the polygon. So that is how the sticker effects work. There, you can use this for things like the blur on zoom. You can use it to lift people out of images and video. You can use it to get really precise area calculations of how much a person takes up in a visual frame. That can be useful for a lot of measurement and photography applications. If you kind of think about what the bounding box of this person is here, it would be very large relative to the actual area that I take up in the box itself. And so when you want to understand in a more detailed way, how much true area does this person take up, you need a technology like this. Okay, great. So any questions about background removal before I move on to our last demo of the day? All right. I'm going to showcase this one quickly before we talk about the code here. And so here, what I'm doing is I'm using our person detection in live stream mode, and I'm drawing a box focused on that person. And so it's going to find the person in the scene. And I take up pretty much this whole frame right now. So it's mostly the same thing. But if I move, it's going to focus in on me as I move about this scene. And so what I think gets really interesting is if you see in the large frame, I am at the very right-hand edge of that large frame. In the small picture-in-picture box, I'm perfectly centered in there. Now, as I take up more visual real estate, it's going to try to get my entire body in frame. And so I can move around the scene. I don't have a ton of room in this office that I'm borrowing here, but I will bring up an example of earlier today. I was moving around in a much bigger space, and I think it's more impressive in, whoop, let's open this up, in a bigger space where you actually get to move around a little bit more and see how that will map to where you are in a scene. Now, I am using just a very simple algorithm here to buffer the frame so that it's not so jittery. I could get a lot more advanced at easing or other types of techniques to where that virtual camera is moving in the scene to follow me. And so let's take a look at the example here. Again, this is in our React example. This is an example of live processing. And so we're going to have a slightly different connection to our worker endpoint. In this use case, I'm giving it a pop UUID that is connected to a person in pose pop. I'm authenticated. connecting and setting up a renderer. The thing that we haven't done yet is setting a stream. And by setting this stream, I am creating a connection between my AI worker endpoint and a stream of visual information. In this case, we're using the webcam, and this stream is going to use under the hood WebRTC with WebSockets to provide information back. And that's how we do this in real time. And so I would instantiate the stream by giving it um, a reference to the stream itself and calling live ingress. That's going to give back a live ingress result that has an ingress ID that I use to process. So instead of processing a file or a blob or a URL, now I'm processing this stream that we've registered with my AI worker server. When results come back into our result object, we are going to put them in a variable called last prediction, and we're going to do some pretty complicated logic. And so let's walk through that logic. First, we need to find if there's a person. And if there are multiple people, I don't want this jumping all over the place to different people. I want to only focus on the person that takes up the most visual real estate in the scene. And so I have this helper function, which just goes through each of these types of objects, so person objects. It's only going to give me back a person object, and it's going to give me back exactly one object, which is the biggest object in the scene. And so once I have the biggest person, I can look for other objects within other objects in that person. If I don't have any, I don't need to do anything, then keep going. If I do have a biggest person in the scene, I'm going to normalize that coordinates to my visual display. That's using the same aspect ratio sort of geometric math that our lift contour used. It's really easy. It's just, figuring out the scaling between the video I'm pumping in, which is coming out of my webcam, and the resolution that I want to display it at. It's going to put into a buffer the biggest person once it's normalized. That buffer I've set at size 10. So the last 10 predictions, it's going to save into that buffer. That's how I'm doing that smoothing from point to point. If I make that bigger, it's going to get slower but smoother. There's other easing techniques I could use to change that around. If we have more than the buffer size, then shift out one of those predictions. So I'm only ever going to have max 10 predictions in here. And then process frame happens every time we render the canvas. We're gonna run this code. What it's going to do is going to get the average person in that crop buffer. So it's following me around. It's going to get my average over the last 10 predictions. And these predictions happen very quickly. I'm running this right now at 10 frames per second. And so that's about the last second of movement. It's going to get my average center. And let's turn on some visualization and let's see what that actually means. And so here, as it spins up, we can see there's a center point here, and here is the average person box. And so that's what I'm visualizing with this white. And so I can see how it's thinking about where I exist in this particular scene by looking at this white box, as well as the center of that box. And we can see that's pretty nicely centered. As long as I'm not, in a weird configuration, it's nicely centered to where I am in the scene. And so this is great for tracking a whole person around a scene. If I wanted to crop to faces, instead of using the center of a person, I would use some of the key point data that we have, like nose, eyes, the ears, and I can start to understand where the face is in that particular scene. I could use that geometrically to crop right into a face if I wanted to. Okay. Lastly, we're just going to draw that picture-in-picture box. That's the little picture-in-picture box right here. And so as we figure out where the center is and how much real estate that person takes up, that's really all we need to draw that tiny person into the corner. I'm always drawing it at 400 by 400. You could have much more complicated logic here if you wanted to. If you want to change dynamically how big that is, or only have this drawn to the screen instead of drawing the preview window here. There's a lot you could do here to make this into a usable product for how your product wants to follow people through the scene. I'm just drawing this out to canvas, and then I'm drawing a nice outline around our picture-in-picture box, and that's this little guy here. So that was a lot, and we're reaching kind of the end here, but Would love any questions if anyone has any questions about any of the things that we looked at today.
Yeah, how about question of what we just were looking at? Now, could you
Yeah.
break that? Say I had this camera trained on, I have two pets. Could I train this on two pets and then separate them out so that I'm seeing, instead of seeing who's closest to the camera, separate the two pets out so that I could see each pet individually if they're in the camera frame?
Yeah, absolutely. That's a great use case. And so you definitely can, depending on which pets they are, if they're different animals, you could do that kind of out of the box with our animals detector. If they're the same animal, like two dogs, you may want to train something more specific, or just like we were looking at in the dashboard, they will get a tracing ID as well. And so you could break up the two objects of interest based on that tracing ID. And so it will track both of them separately through the scene. And you can basically do this same algorithm, except use your animal of interest and add in the tracing ID to separate, hey, I have one dog over here. He has tracing ID 5, and I have another dog over here. She has tracing ID 8, and dynamically separate those two visually.
Would that tracing ID have to be regenerated each time the camera comes on and offline?
It is, yes, but it happens automatically, so you don't really have to think about it. You just know they're distinct numbers, so you can treat them sort of like UUIDs, where you know it's a unique they're unique concepts.
So it would know this is Buffy and this is, Sloppy.
Yeah, I mean you can assign like the names to it, but it would say, this is dog 8 and this is dog 3, and so they're separate dogs.
So let me ask you this. I don't want to take up too much of everybody else's time, but could we get as granular as to say Buffy is being active and Sloppy is sleeping?
Yeah, and so we've had actually that sort of similar case that we were helping a client with in patient care. And so what they were doing is they were actually looking at key points on the person's body and saying, are any of these moving over time? If not, that person is at rest, or and if they are moving, like they're definitely doing something. Are they moving through the scene, like walking around, or are they just moving their hands, but they're sitting there or lying there? So there is definitely a lot you could do around the relative motion over time of those boxes that represent the animals of interest.
Can it get as minute as detecting breathing as a presence detector? Will?
That one we'd have to experimentally test. I think that one is going to be highly dependent on the resolution of the camera that you have pointed and how close they are,
Sure.
because when you start to get to like fine grain pixel movements, that's going to be environmentally dependent. So I would say maybe, depending on the setup.
Nice.
All right.
I'll
Anybody
give
else?
I'll give some other people a chance to ask questions if they
Oh,
will.
sure. I mean, love the questions. I like this concept of where you're going. And if you want to join our Discord, love to answer your questions on our Discord. My email address is andy@eyepop.ai. Happy to field questions there as well if there are
Okay.
questions after this. But we'll be sending out a link to this recording as well as some of the other ways to contact us and build on iPop. Great.
There.
Well, thanks everybody for joining today. Uh, Additional sensory data to gauge on breathing. Yeah, I agree. Maybe temp. Our models do generally work with thermal data, so you could think about that. There's other classification we could do around breathing and activity that you could do later. And then how do I talk to your team one-on-one? Andy at eyepop.ai. Hit me up. Happy to connect you to whatever part of our team you need to, or myself. So thanks everybody. This was great. We're going to be doing a bunch of these, and so please sign up for other series. We'll be releasing them after the fact too. So even if you just want to sign up and we'll send you the recording later, that would be great. Thanks. Have a great day.